If you've been to one of these before, welcome back. If you haven't, then greetings. My name is Will Stroh. I'm a principal support engineer here at Qumulo. And today we'll be talking about adaptive data protection and transparent platform refresh, which is a mouthful. Just for clarity up front, we are going to toss around a few terms here. Adaptive data protection, colloquially in-house, it's known as ADP. Transparent platform refresh, I'm already saying it here, is known as TPR. There was a time when that was actually known as transcode. So if you hear me toss that one out, I apologize. The engineering team realized halfway through that that was a very popular topic within M&E environments, and it meant something entirely different. So we'll go ahead and stick with transparent platform refresh, but like I said, if you do hear me say transcode, then you know what I'm talking about here. But for the most part, we're talking ADP and TPR. So let's pop right in here. We click on the right side, maybe. There we go. So what is ADP? In short, it's the ability to swap out your erasure coding. You can also change up fault tolerance if you want to. As you can see on the screen, only takes place during a node add, and we're going to tell you which version to go with. Recommendation is going to be 6311 and above. There's a few caveats for why that's the case. Technically, it was introduced earlier, and so if you are in an older release, reach out to us and we can see what we can do there. But more often than not, you'll want to be shooting for the later release there. Now, where we say it's available during a node add operation only, there is no other way around that, unfortunately. It does need to have the node add take place so that we can swap things out. Now, as everyone knows, when you came to Qumulo, they said, hey, you got to get a 4-node cluster, bare minimum there. That gives you the erasure coding of 6.4. It's not great. It's not bad. It's the default that you get. So with ADP, what you can do is as you get a larger and larger cluster, if you were to stick with that 6.4 erasure coding, you're really going to be sitting around 60% efficiency for a good while there. Which, again, it's not bad, but it's not great by any stretch of the imagination. So with ADP, we let you actually change that up. So, for example, here we've taken a 4-node 432 cluster. It is 6.4 erasure coding, fault tolerance, 2 disk, 1 node. That's normal, 61% efficiency. Great. You got, petabyte of space out there, give or take. If you were to add a 5th node, just straight up here, and not change the erasure coding, you're adding about 300 terabytes, round numbers. If you change that erasure coding to a much wider stripe there, to the 8.6 erasure coding, as you can see, that's that efficiency that bumps up there a good 8%, and you're actually gaining more space than you're adding, if you will. So the C432 ballpark number, that's 432 terabytes. If you look at it there, you're actually adding about just shy of 500 terabytes, about 450, I guess, 460 in there. So you're actually adding more space if you can change that erasure coding. So it almost makes sense if you are going down a road of just like for like, adding a single node there in that case. It makes a whole lot of sense to go ahead and partake in the ADP portion of that, and you'll see, like I said, you're automatically gaining 500 terabytes here. If you look at the comparison, you're gaining 200 more than what you started with. So straight up, that should be a no-brainer, but there are times when you may or may not want to do that. Let's take a look at another example here. Here's the straight up how you do it on the command line, and certainly let me pause here. If you have any questions during this, feel free to ask. I do kind of want to address these while we're going through it, because ADP and TPR, they can have different answers depending on how we address it. So throw them out there, and I'll try and keep an eye on those. So here we are doing it on the command line. And this is a good point. This is only available via CLI. I think it should be able to do it via API as well. It's not going to be built into the GUI though. In this case, we're doing an add node command. We give it the node UUID, and this is going to be our fifth node. And we're giving our target stripe configuration. We're going to an 8.6 erasure coding. Now we're keeping the same node failure here as one. This dry run on the tail end here, that is strictly for making sure you're doing the command right. Both ADP and TPR do not have a oops, I need to back out feature to them. There's not an option for that. So with the dry run, it will not actually commit anything. It just tells you what's going to happen out here. Now, if you take that dry run off, it still asks you to confirm that you want to do it. But with the dry run, you do not get a chance to confirm you want to do it. It just pops back out at that point. So all these commands in here, if you're taking screenshots, you will see this -- dry run on there. Again, obviously, just pull that off if you need to. So this here will give you what we're looking at here. This would give you this with ADP 5-node 8.6. Oops, whoa, went crazy there. 8.6 erasure coding, 70% efficiency, 1.5 terabyte or 1.5 petabytes usable out there. Pretty straightforward operation, not a whole lot going on there. In this example here, we're going to mix things up a little bit. We're still going to 5 nodes. We're still going to go with ADP on there. However, we're actually going to change our fault tolerance at this point. So you'll note, here's some insider baseball information. If you go back, here, let's go back to this one. Note the 6.4 gives you 2 drives, 8.6 gives you 2 drives. The difference between those two tells you how many drives you have to fail. So people pay a lot of money for that information. I just gave it to you for free. Right? Make sure you include that on the next NPS results. So here we got going our 5 nodes. This time we're actually changing it up, though, to a 3-disk 1-node failure. That's going to drop our efficiency because we are giving you extra protection domain out here. You will note the usable does drop substantially. You're losing about 120 terabytes from where you'd be at. However, you do have that 3-drive failure there. Now, realistically speaking, with 5 nodes, do I need a 3-drive failure? That is entirely up to you as a business to decide on that one. Honestly, I would probably say don't, simply because when a drive fails, you only have to wait for that reprotect to finish. You don't have to wait for the new spare to show up on site. Once that reprotect finishes, you'll be back to your initial 2-drive 1-node fault tolerance. But there are cases where this may make sense. There's a customer I've dealt with fairly exclusively out on the East Coast, where given their location and typical snowstorms and whatnot, we have looked at changing things around there. Right now they have some on-site spares that address that issue as far as like chassis, if you will. But it is something to keep in mind if you are in, Antarctica or someplace. You may want a higher fault tolerance there. Those penguins have been known to run away with those drives. Alrighty, so changing it up here, you'll note the only difference is this target stripe config. That's all we're changing there. And this will go through, it'll prompt you, is this what I want to do, et cetera, et cetera. Now let's throw a crazy example out here just for grins. This is going from a 10 node to 24 node. Obviously, that's a heavy lift at that point. But if you got the rack space for it, great. We're doubling our capacity out here. And again, in this example, we're going from a 3-drive 1-node fault tolerance up to 4-drive and 4-node. So again, if we looked at command line out here, our target stripe 2016, the difference is 4. So there's my 4 drives. Max nodes failure, 4, cool, dry run. In this case, we don't actually throw our UUIDs out here. We are just doing an add nodes -A, capital A. That will do all of those drives, or all of those nodes, forgive me, all unconfigured nodes. So it's something to keep in mind if you are in a situation where multiple groups may have Qumulos on the same network, you may want to shy away from doing the -A there, because it is going to be a case where It will go out and grab anything you can talk to over IPv6. Now, one question that does come up from time to time is, how much space do I need to pull this little maneuver off? Because you are going out there and you're changing your target stripe, we do have to rewrite all that data. In a very basic form, you can think of it as just a regular restriper going through and rewriting your data. However, it does need a certain amount of space for it. Rule of thumb is about 10%, give or take. If you're close to that number and you need to find something exact, certainly reach out in your Slack channel, reach out to your CSM, reach out to your favorite CSE if they've given you their phone number, and we can discuss that and see exactly where we need to be at for that. But by and large, 10% is a good rule of thumb. What will end up happening is it will go through, rewrite that data, move things back. Now, this will all be monitored via the regular restriper. So if you do a QQ restriper status, you'll see the output there. If you look in the GUI, you'll see the output there as well. As that moves along, it's really just a case of doing a partitioned rebalance at that point it'll come up as. And once that finishes, you're good to go. You have a new erasure coding on there, no muss, no fuss. As I said, you do need that 10% out there. So if we are in a situation, let's jump back here some and just play with these numbers. If you are in this situation here, and I want to add a fifth node, but let's say I'm sitting currently at 1.045 terabytes out of my 1055. Probably don't have enough space there at that point. That in those cases, you can either try and free up some space. Perhaps you have a replication you can move things off to. Delete old data if you can. Alternatively, one thing you can do is if instead of 5 nodes, let's say you had 6 out here, you could add a single node just using a regular node add. Wait for that node to be added, get that free space, and then add the second node. And at that point, do the ADP change up there. Either way works perfectly fine. It's really no different than if you had started with 5 nodes and added 6. But it is something to keep in mind there as you move forward through things. Now, as I said, if you got any questions, please feel free to toss them out there. Okay, we're going to roll through transparent platform refresh, and then we have a kind of an FAQ lessons learned at the end of this here. So we will touch on those things. Now, the TPR is a little different than the ADP portion of it. This gives you the ability to swap out your nodes. Now, I spent 14 years at a competitor. They look like a big blue pair of pants, if you want to guess who that might be. And they did not have a way to remove nodes out of there. In fact, no one in the industry did that I'm aware of. So if you were to move to a later and greater platform, really your only options were to either copy the data over to it via replication, via mirroring it over there, et cetera, or actually, sneaker net it over there using rsync or something like that. Do the cutover, and then at that point, take the old nodes offline, hope everything gets updated, and move on with your life. With TPR, we've changed that scenario. At this point, what you will do is you'll actually rack the new nodes right next to your old nodes. You will go ahead and put those into, you'll basically add them into the cluster. They will have static IPs, they'll have floating IPs. And at that point, we will start copying the data from the old nodes to the new nodes. So we'll do a rebalance across everything. Then we'll start the transcode operation. And then we'll do another rebalance at the very end to clear things up. And that's where those multiple phases comes into play here. So it's not a immediate operation as ADP is, where ADP is effectively a single pass through there. boom, takes care of everything. You're good to go. With TPR, it's usually three-ish phases, I want to say it is. It might be 4 these days. Again, as with ADP, we're going to recommend a version out here for you. I don't foresee this changing anytime soon. There were a lot of caveats that came into play with that one. So the other important thing, bullet point number 2 here, usable capacity cannot decrease. So if you had 1 petabyte of data out there and you're going to TPR that thing down to 4 nodes of something new, you still got to have at least one petabyte of free space out there at the end of the day. All right, so let's take a look at how this monster works. So here we have 4 nodes of QC208 out here. It is my default 6.4. I got 2 drive, 1 node fault tolerance, sitting about, half a petabyte of space. If I TPR this thing straight up with some 432s, 4 node to 4 node, like for like, because 4 is my bare minimum. Again, I use a 6.4 encoding because that's what comes with a 4 node cluster. Gets me about 61% efficiency, but I have doubled my space effectively. So during this time, I would have the 208s racked and operational. I'd have the 432s racked and operational. Now I throw this 5th node out here just for grins. You know, in this case, maybe you don't want to buy a 5th node, but because you can do an erasure coding change with TPR, if you were to throw a 5th node on there, that again jumps up your efficiency, and you see in this whole operation we'll end up with a petabyte and a half of free space. So if you have the ear of the decision maker in your organization, it may make sense if you're going down a TPR road to go ahead and run the numbers for something that is 1 or 2 nodes more, just to see if you can get that additional erasure coding, and see where that leaves you at that point. Because as you can see, you're gaining 9% more efficiency out here. And, you know, at that rate, you know, maybe that buys you an extra year with a single node as opposed to having to deal with it later. If, you know, as we roll things out here, as these 208s get evicted, at the end of the day, you know, I ran the numbers on these things. You are saving about 3,000 BTU out there. Now, that's British, I'm American. We fought wars against those people, but I understand that's an impressive number. And about 1,000 watts, that was by Ted Watt. I think he made that number up there. Again, these are all things to keep in mind, that you're actually going to a cheaper data center, if you will, at that point. So if you take a look at these things, you know, again here, the top one, we're going to do it with 4 nodes. Bottom one, we're actually doing it with the target stripe change. So again, nothing magical here. It's pretty straightforward. We're running the replace nodes command, add nodes and replace, all unconfigured nodes, do a dry run on it. On the lower one, that's if I have that 5th node in there, we're changing that target stripe to 8.6. Again, if you're new to Qumulo, default is going to be 6.4. That's what comes with 4 nodes out there. If you want to change that to anything but 6.4, you are going to have to go to a higher node count at that point. Alrighty. So here we have another example here. I'm taking a 35 node 168 cluster. I got an erasure coding out there 2017, so 20 minus 17, 3 disk failure. I got 3 node fault tolerance. Got roughly 4.8 terabytes usable. I'm going to roll this thing out to basically half the space, half the number of nodes out there with my 432. Roll down to 16 nodes. The erasure coding is going to change. We're still going to keep that 3 and 3 out there, but as you can see, we're getting about another petabyte, not petabyte, 200 terabytes of usable space. The bigger concern here is from an infrastructure standpoint. That saving of 38 ports on the network is apparently a huge number given network switching these days. So by and large, you know, it's taking the same amount of space, My BTUs and my watts, they're not that big of a change, but the big one is that 38 ports out there. So it is something to keep in mind as you go through these motions. The one usable number may not be the only thing to keep in mind. So if we wanted to run through this guy, we have this whole mess of stuff up here. Now, the reason I put this all up here is a couple reasons. One, it shows you what you can do with TPR. Now, I noticed a few of you on the call here, we've probably gone through this in the past. This is old hat for you. For those of you who haven't, listen up, pay attention. We're going to show you some magic that you can do. So first off, we're running this replace nodes command. Again, nothing different there. That was the same as what we're in here. Replace nodes. But instead of the add nodes and replace, I'm going to do a register plan. And with that register plan, I'm going to tell it which nodes I want to replace. I want to replace, in this case, 1 through 35. We're going to give it a target stripe and a max node failure. Cool. All that stuff is good. Dry run that bad boy. Now, the only output of that, if you take off the dry run, is it'll say plan register. It's pretty anticlimactic. Now I go ahead and run my replace nodes command. Add nodes and replace, nodes been replaced. In here, I'm using the Unix verbiage, if you will, the curly brackets, to do nodes 1 through 10. And then I give it a listing of the UUIDs that I want it to do against. So what this is going to do is this will add in nodes 1 through 10 and rebalance over to those. Now, I can come back at some later point and finish my TPR process. So at this point, once I do this nodes replace, it's going to toss out nodes 1 through 10. So if I have a limited rack space, this will toss these nodes out, evict those, and now I can move things around or whatever I need to do. And now I can continue replacing the rest of the nodes, replace all. And at that point, I do a reconfigure data protection. So you can do the TPR in multiple steps. This example here is actually straight from a customer who remained unnamed, where we needed to do it over a range of time due to exactly that. It was limited switch ports. And so as we went through things here, I want to say the whole operation ended up taking 2 months just due to timetables and whatnot. But it was a very clean operation where we were able to run it against the first round of 168s and then toss those out at the end of it, free up those switch ports, and then continue along with doing things there. So there are some options you can do, and it's good to keep those in mind as you roll forward. It doesn't have to be all one and done at a single time there. You know, we can move things around some. All right, so questions we get asked from the support side. Where's my space? Well, it's not going to be seen until the entire operation is complete. And that's the same for ADP, it's the same for TPR. You will not see it out there. Now, if you're doing a normal node add procedure, you will slowly see that little capacity donut grow in size as it goes through and rebalances space around and decides, oh, hey, I got new space out here. But with these operations, again, you're not going to see it until it's complete. How long does this take? Very good question. The rule of thumb we tend to use is you take your used petabytes on the system, let's say it's 1 petabyte to make it easy for me. You multiply it by 5, so you get 5, and you add 4 to that, so you get 9 days. There have been ADP situations where you could set your clock to that, and it was amazing. There have also been ones that have ended up happening way, way sooner. You know, we'd quote a customer about a week, and it would end up being 2 days. There's a lot of variables in play here, and that's what makes it really difficult to determine the actual a fair number for that estimate. So we do tend to go on the high side of things. And if it comes in sooner, great. That's amazing. But I've yet to see it actually take longer outside of situations where you had something, a drive fail, a node fail, whatever, outside of infrastructural issues, I guess you can call them. Outside of that, that is a very fair estimate for the ADP side of it. For TPR, it's an absolute wild guessing game. we can quote you a number on that, given some hefty math, but honestly, it ends up being very, very long-winded estimate, if you will. The best example I have is our prior 168 customer there that I was just showing you. We had quoted them about 60 days, and we came in, I think, at 23 days for that. So, there are cases where, it's also going to factor in the load on the cluster and whatnot. So, like I said, there's a whole lot of variables in play. Reach out to us if you need to get a very clean estimate on how long it's going to take. But odds are, just keep in mind, it's going to be on the high end of things. Now, I did say early on, you can monitor this all through the restriper status, which is true. It'll perfectly show you things out there. With the ADP portion of it, it's a little cleaner in that there's only that partition rebalance that needs to take place. With TPR, I think I said there's 3 phases, or it's 3 or 4 phases, but you'll go through to a partition rebalance, do a transcode, do another partition rebalance, and then a final rebalance possibly if it needs it. Those will show up in the restriper status. However, some of those operations will not report. They'll report, but as 0% out there. So you may see it sitting at 0% for a long period of time. If that is what you're seeing, and if that does concern you, reach out to us. What we can do is we can actually force a restriper status or restriper report from the system and actually pull the data out that shows that the transcode operations are taking place in the background or what have you. So it's a 5-minute operation. It's not a real heavy lift. So by all means, feel free to reach out there. We got a question here. What happens if a drive were to fail during the TPR process? Excellent question. That's my next bullet point there. So if you were to have a drive fail, or if you were to have a node fail even, the operations are going to pause. So as it goes through, if you want to think of let's use ADP as an example, just gets a little easier because you're only dealing with one restriper process there. As you add those nodes and change the erasure coding on there, you can basically think of it as a big giant timeline. I got a first grader, so we deal with timelines a lot. Starting at 0, ending at 100. Great. It's going to start over here at 0, work its way along. Let's say it gets to 25%, and then you have a drive fail. Well, at that point, it's going to pause because it can't do anything with that. And if you don't like drive fail, you can say a node fail. Either way, it's going to be the same result. Once that is replaced and reprotected against, and you're back to a quote-unquote healthy state as a system as a whole, not just the normal reprotect where we say, okay, yeah, you're still down a drive, but we're protected. Nope, you have to have full complement of drives. Once we're back to a state where we have all the drives or all the nodes back online and happy, at that point, it will pick back up again. Now, depending on which release you're on, restriper will either show you the proper status of where it was at. So if you got to 25%, it'll pick up at 25%. Or it may show you 0. If it shows you 0, that does not mean it's starting from scratch again. It doesn't mean that by any stretch. It is starting at 0 from where it left off. So you already had 25% in the kitty there. We're starting at 0, so basically you have 75% more left to do at that point. I have seen both ADP and TPR operations take place where we have had drives and nodes fail, and it works perfectly fine. I've not had any hangups on it. I mean, at that point, really the only holdup is is how fast you can get new drives out there. So another common question: can it change my non-encrypted system to encrypted? So if you've had an older cluster, I want to say it was 3.1 where we made the changeover to software encrypted at rest. So if you were coming from something before that, you would have upgraded through the path just fine. You would have stricken your fist in anger at having to hit every single release of the 2.12 and 2.11 chains. But you would have been in a non-encrypted state. Neither one of these can go ahead and change that for you. That can only take place during the initial install. So if you are on one of those old releases, or came from one of those old releases rather, or if you are on it still, not to say that we don't have any customers on those still, and you want to switch to something encrypted, then this is probably not the best method for you, unfortunately. If you were, if we jump back here, just for grins, if you were this situation here where I had these QC 208s, where I have 4 nodes on here, and let's say those came in at, I don't know, 2.5 or 2.6, right? We don't have software encryption at that point. But let's say we want software encryption on there. What you could do would be to create a 4-node C32 cluster, copy everything over to it, and then you could do a TPR with this 5th node at some point in the future. Or if you had 5 nodes to begin with, you could just create it as a 5-node 432 and then replicate all that data over there. If it's not a concern to you for the encryption at rest, then really it's a moot point there. But just keep in mind, it cannot change that. So like I said, if you are coming from something, I want to say it's 3.1. A customer did actually ask us about that the other day. It is something to keep in mind. Okay, transcode can be paused. So, and realistically, ADP can be paused as well. Transcode seems to be the bigger mover, if you will. If you have a situation where you have very latency sensitive applications, transcode is going through and making a whole lot of calculations and operations on the back end out there. So given that, it may be a situation where you only want to run it on the weekends, in which case we can go in there and we can show you how to do it. You would pause the transcode process. So the next time it picks up a chunk of data to do, it would say, oh, I'm going to pause here. And then as soon as you want to kick it off again, we would go ahead and unpause it, and it would move things along. Additionally, if you don't want to do that sledgehammer method, pardon me. Additionally, we can limit how many block chunks it does at a time. I have yet to see a case that actually required that. The pausing we have done on numerous occasions, again, simply because it was a very latency sensitive applications that were taking place on the back end. I haven't changed, like I said, I haven't changed the chunking yet, but it is possible if you need to. So static IPs will stay with the nodes. So prior to 6.3, if you were to add a node in there, into the cluster, you had the possibility that it would reshuffle your IP addresses out there. And it basically would come into play if the node 1 always wanted the lowest static IP. And so if you're adding 5 nodes and you need a different IP space and you happen to pick a bunch of IPs lower than that, oh my gosh, it's going to go ahead and jumble all those up. Not really an issue, but if you did have applications that, for whatever reason, we're talking to the static IP, suddenly that's going to be a problem and concern for them. After 6.3, that's no longer a problem. The static IPs stick with the node. So if node 1, if I go back to my example here with my 208s, if I had IP.1234 here, and I'm adding .5678, when this TPR operation completes, I will only have .5678. 1, 2, and 3, and 4, those have now been evicted. They stick with the nodes. So it is something to keep in mind if you are, it's more of a concern, I guess, when you start dealing with these numbers of nodes getting swapped out, where I have 35 static IPs at this point. If you do want to keep your IP ranges coherent and meaningful, you may want to go ahead and schedule some maintenance after the fact to go ahead and change those up. It's not required by any stretch, but it is something to keep in mind. My floating IPs, those will be reassigned. So again, if I have, if I go back to this guy over here, I got 4 static IPs. Let's say I have 2 floaters for each of these nodes, so 8 floating IPs. I'll add these in with static IP. So I have those 4 static IPs. My 8 floaters will roll over to all onto these nodes once everything completes. Once these get added in, straight off the bat, I'm going to have 4 floaters roll over here real quick. But those remaining 4 will come over after the fact. Okay, nodes will remain powered on at the end of the operation. So this came to task basically, pardon me, we're making some changes with code, and it was initially with TPR, we actually powered the nodes off so you know which ones you're going after. We ended up making some changes, and it became more of a heavy lift to actually power those off at that point. So at this point, we keep them on. Now, the unintended side effect of this actually worked out in our favor, where because you'll have those nodes still be powered on out there, you can go ahead and do things with them at that point without trying to figure anything out as far as, which nodes are which and whatnot. One common thing that people do tend to do afterwards is they will recycle these nodes, if they don't have a need for them in house, and part of that includes wiping those drives. Now, with Qumulo, you can drop a USB image in there, and it will quote unquote zero your disks, which is basically on par with DOS writing a question mark to the end of your file back in the day, and the file wasn't seen anymore, and whoa, it magically went away. So you can go that route. There's no problem with it per se, but just keep in mind the data blocks are still technically out there. If a bad actor were to get a hold of those, could they bring them back? Hard to say, to be honest. I don't know how much effort you want to put into it, but if you want to err on the side of caution, I would say don't go down that road. What you can do is we do have disk shred. We have shred built into the system, so you could certainly boot the system up to the kiosk screen, bounce down to the command line, and then run shred at that point. You can tell to do a 7 pass on there, which I'm told is DoD compliant. Likewise, there are some other systems out there. You can boot to a USB, go through and clean things out that way. It really is up to you at that point on how you want to handle them, and how concerned you are, I guess. I mean, realistically, you need the whole stripe to actually get data off there, unless the data is less than 4K. So, I'll let you make that distinction on how important that is to you at the end of the day there. All right. Lastly, as we open with this, there is no, oops, I need to turn this back off. I messed something up. We don't have a big button for that. So you'll note, again, all these examples out here, this dash dry run on the tail end of it. I do these things probably once a week. I still throw dash dry run on there. I don't trust myself, to be honest. So outside of doing that and making sure it looks right, I would highly recommend reaching out to your friendly neighborhood CS, and we can look over it real quick for you. Likewise, if you're having PS come on site to add nodes, they should be able to go through the same motions with you and get a good idea for if it's going to be the right command, wrong command, what have you. All right. Any other questions out there short of my drive failure one? I'm not seeing any. So everyone's going to go out and go buy a bunch of nodes now, and we'll TPR them up for you and get you a whole bunch of space. Thanks a lot, guys, and we'll see you next month. If you got any questions, please feel free to reach out in your Slack channels. And if you see any talking dogs, be sure to feed them tacos. Thanks.